Hey everyone, welcome back to Scopes by HPU. Will here, and this is the focal point video for the Astrophotography lens. So this lens is pretty interesting. We have something pretty fun in store for you today. So this lens involves you taking images from Skynet and turning them into what are called true color images. As you've noticed by this point, all of the images you get back from Skynet are black and white, but we can actually use color filters in Skynet observations and then use a different piece of software called Photopea to allow us to take those filtered images and turn them into colored ones. We can actually make our own really cool multicolored images of stuff out in space that comes from black and white images off of Skynet telescopes. I know this is really wild and I hope it's going to be really fun. So today I'm going to show you how to actually put in an observation into Skynet for an RGB filters. The process is actually different than looking at previous objects like you've done before. There's going to be extra steps you need to take when you're observing an image in an RGB filters for the purposes of creating a true color image of that object. Whereas before we could just simply put in an observation and that was that, we have a couple of extra steps we need to do today to allow us to actually see these images in the color filters that we'll be working with today. So I'm going to hop over to Skynet and I'm going to show you how to put in an observation of an object for an RGB image as opposed to a regular observation of that object. Alright, so for my RGB image, I'm going to go ahead and do a nebula. Now you can do any object of your choosing. I'm a little biased and I think nebulae look really awesome in RGB, so I'm going to go ahead and look at a nebula. I'm going to look at an old favorite, the Trifid Nebula, that you might have looked at during the nebula lens. Again, you are welcome to look at any object that we have looked at so far for scopes. I'm just choosing Trifid because I like it. So we need to check the air mass chart, like always, and we got some sites that can see it. So now that I know my object is observable, I'm going to do one quick thing similar to what I did in the Galileo lens. I'm going to rename my observation. So you know how in Galileo you added the moons to the end of the name, help you better differentiate between an image of the planet you're looking at versus the moons of that planet? I'm going to do something similar here where I'm going to add like maybe an RGB or color images, something along those lines at the end of your observation name to help you know that you're looking at an observation of the object in an RGB filters as opposed to regular high or low through filters. Again, you don't have to do this, but it is something I would recommend doing to help you keep track of all of your different observations so you don't get confused. So now that that's out of the way, let's go ahead and move on to the next steps. Now, the order here is going to be sort of inverted. Instead of choosing filters and then choosing telescopes, we're going to choose our telescopes first. We're using specialized filters that are not available in every single telescope, so it's best to pick the telescopes first. That way you know what kind of quality of image you're going to get first before you apply the filter. That way, if there's a specific telescope you do like, you can see if there's actually availability for it in RGB. Like I said, it's not available to everything, so let's go ahead and do telescopes first and then we'll select filters. So we'll select telescopes now, and I'm going to do the tried and true classics, things like RCOP, the prompt scopes. Let's do prompt number 1 as well. Again, you're more than welcome to select whatever telescopes you desire. I'm doing these because they're my favorites. But at this point, I think you've become accustomed to trying out different telescopes, so go nuts, pick what you want. Now that we have our telescope selected, we're going to move on to filters. So here's another big difference between regular observations and RGB ones. We got to use different filters. We are going to be using true color filters as opposed to other filters that you've used in the past, which are simply filtering out brightness levels. This is actually going to be filtering out specific colors. The filters we'll use are going to be under this Astrophotography filters, this big orange drop down. So you drop down this, you'll see tons of different colors here. H-alpha, lum, and then RGB, red, green, blue. We're going to select red, green, and blue. That's all we need for right now. Make sure you select all three. After you've picked those, we'll go on to our exposures. All right, here's the last big step in making sure that an RGB image is taken correctly. You need to do a single observation for each color filter. What will happen is a telescope will take an observation of that target in one filter and then do it again in another filter and then again in another filter. So each observation needs to be taken the same amount of times and each observation needs to be the same amount of time. So if I were to put in one observation in a red filter, I need to put in one observation in green and one in blue. If I want to do 2 in red, then I would have to do 2 in green and 2 in blue. I'm just going to do 1 for everything for right now just to test it all. And again, the observations need to be the same duration for all 3 filters. The Trifid Nebula requires a 40-second observation, so I need to make sure that I submit that in every single duration for all 3 filters. If you don't have the same amount of time for every filter, the images may not line up properly and your RGB image may not be the best quality in the end. So make sure that everything here is all the same. All right. Last thing we need to do is we need to mess with these advanced options. We've never had to mess with these before, so let me take some time to walk you through them. We've always selected sequential filters, that's the default. What that means is that if you're taking multiple observations and multiple filters, it'll do one and then another and then another and then another. Interleaved is complex and it does multiple filters at the same time, which is not exactly what we're going for right now, so we will still use sequential. But the thing we need to change is that we need to select all exposures on the same telescope. By having this option selected, all 3 of our exposures will be taken on the same telescope, one right after another. They may not be taken immediately after one another, back to back, like within minutes of one another, but this will ensure that all 3 observations will be taken from the same spot on Earth. That way all your observations will line up well enough in the end. While I'm in the advanced options, I just want to show you that you can also select when you want this observation taken or how many times you want it repeated within a certain time frame. So all of this is free reign to play with on your own, but for right now, the only things that you need to make sure are selected for RGB filter images are sequential filters and that all exposures are on the same telescope. Now we'll go over and submit this observation. So like we've seen tons of times before, let's just review everything. I've changed the name to help differentiate between an RGB image of Trifid versus a regular one. I have my telescopes. I have my 3 observations, each one in a different filter, each one the same amount of times, and each one with the same duration. I've made sure that I'm selecting on the same telescope, and that's everything. So just a couple of different steps, but please make sure that you follow this pretty closely. Otherwise, your RGB images will not come out the way that you need them, or definitely not the way you want them to in the end. So if you follow all of these steps correctly, then you should have a really great RGB image waiting for you once you submit this observation. And once we submit it, there we go. Now you have submitted an observation for a true color image into Skynet. Now remember, the goal of the astrophotography lens is to create a true color image of any object you want. We ask that you take any object that you have observed in the past from any of the previous lenses, a planet, a galaxy, a star cluster, whatever you want, and that you then observe that object in the RGB filters like I just showed you how to do, and then turn that image into a true color image. You only need to do one to submit as part of the application, but of course you are more than welcome to do as many of these as you want. This is a really fun and really cool process that lets you be really creative and have fun and take control of some really cool images of stuff out in space. So go nuts, have fun with this. And that's everything I need to cover for this lens. The astrophotography lens is something that I hope you guys find to be really fun and really exciting, turning black and white images into these amazing colored ones. With that being said, I have some bittersweet news. Astrophotography is the last lens of SCOPES. So if you're accomplishing this lens, that means you've made it through the entire program. So first off, congratulations to you for making it this far. I really hope that you've enjoyed your time. Second off, I'm unfortunately going to say that this is the last focal point video. Yeah, it's been a fun ride, but that's everything. I've taught you all everything you need to know to do everything in SCOPES, and I hope that you've had a fun time listening and joining me along the way. With that being said, I'd like to close out the last focal point video, and thank you all for joining me on another edition of Scopes by HPU. And remember, keep looking up.